These wonderful photos of yellow warbler, black and white warbler, and blue-headed vireo were taken by one of the members of the Strickland and TFN nature class this past week. This is a wonderful season of the year when these tiny little birds start to arrive in Ontario after a 4,000 kilometer flight from Central America or South America. Here is a map of North America. This gives us an idea of where they have spent the winter down in Mexico and the countries of Central America. Sometimes they've crossed the Gulf of St. Lawrence and they're going to be nesting up in Ontario, sometimes up in the boreal forest, but even right here around Toronto. Flight is a miracle, and the fact that these tiny birds can navigate, can find their way, is a miracle, but it's a miracle that they can fly at all. So this video is going to be just a look at how the bird's body is adapted for flight. So a bird's body has the same bones as ours. These are the bones from a chicken wing. So the upper bone is the humerus, and if we grab hold of the upper arm of our upper bone of our arm, it's the same. We just have one bone in that position called the humerus. The lower arm, below the elbow, has two bones in a bird's wing and two bones in our arm. We can actually feel both of those. These bones would be the bones of the wrist, and then the bones of the fingers are fused together. And the flight feathers are attached to that. So the bird's body, the bird's body is adapted in that the arm has become a wing. And one of the things that a wing, one of the ways that a wing is specialized is that it has this curvature. So this is the leading edge of this duck wing here, this merganser wing, and the wing curves up from the leading edge and creates what we call an airfoil. So as the wing moves through the air going over that airfoil moves faster and creates an area of low pressure, which gives the bird lift. The bird can change the curvature of that airfoil so that it gets more lift or less lift, depending on how it wants to move through the air. So we mentioned that the flight feathers are attached to the fingers, which are fused together back here. There's also a tiny little extra wing here, which is a little bit tricky to see on the duck, but it is used by the bird when it's going to land it pops up to break the air resistance. So there's many other ways that a bird's body is adapted for flight. A lot of us are familiar with this bone. At Christmas time, we've played that game where two different people grab hold of the two different sides of this bone, pull it apart, and the person that gets the top gets their wish. And this is actually the collarbone. So if we feel our own collarbone, we can tell that it's very it's horizontal. It isn't anything like this bone, but this is the corresponding bone in a bird's body to our collarbone. And we can see on this reassembled skeleton here that the position of this furcula or wishbone is right at the front of the bird, in the same position as our collarbone is, but it's a completely different bone. This bone, the wings are attached up here at the top of just above where the furcula is attached on both sides. The bird's flight muscles are attached down here to the breastbone, they travel up here through this little hook here and attach to the bottom of the humerus. When they contract, they pull the wing down. So when the muscles contract on both sides and pull the wings down on both sides, the furcula is pulled apart. It acts like a spring, and when the bird is ready to raise its wings upwards, this bone pops together again and it has stored the energy of the downstroke so that the bird doesn't have to work as hard to raise its wings back up again. So that is a miraculous kind of an adaptation for flight, that the collarbone acts like a spring. This little hook up here also is quite an amazing thing, because the bones that elevate the wing, or the muscles that elevate the wing, travel from the breastbone, pass through that opening, and attach to the top of the humerus, so that when they contract, they actually pull the wing up. The breastbone, our breastbone, when we feel it, is very flat and fairly small. It's the place in our chest where the ribs attach. You can see that the breastbone of this chicken is quite deep. The flight muscles are attaching here, and when they contract, they bunch up against the breastbone. So when we're eating breast meat, we're actually eating the flight muscles of the chicken. But it needs to be deep like this so that when the muscles are contracted, they have something to pull against. The humerus is an amazing bone. So this is actually the humerus of the turkey. So the humerus, you remember, is the top bone, the bone just attached to the shoulder of the arm. And when we look inside this humerus, which has been opened up, we can see that it's basically empty. It has very, very thin walls compared to the walls of a mammal bone in the same position. And the reason for this, of course, is to make the bones very light for flight. But the humerus also has this opening at the top, which allows it's the opening for oxygen to be stored in the bone. So there's actually air bags in the bones, which store extra air so that when the bird is breathing out, fresh air from the bones can pass into the lungs. So the bird never has a period when they have breathed out and they're not getting fresh air. They have a constant flow of fresh air because of the extra bags of air that are stored in the bones. One other interesting fact is that's very available to all of us if we think about it. A bird's neck is made just like ours with various vertebrae. It has lots and lots of mobility, which is very cool. Our neck has about 6 vertebrae, but a bird's has 13. Why does a bird need such a long neck? A bird doesn't have the use of its hands for picking things up. So the neck has evolved to take the place of hands in a bird. It can move its neck all around and pick things up off the ground. So feathers are also a very important part of the bird's adaptation. And we can see that the bird's feather is made of barbules like this. If a bird's feather gets struck by a stone or something, or hit by high winds and it breaks apart like that, it's very easy for the bird to repair. It just runs its beak along there and the barbules latch onto each other and repair the break. This is a wonderful, that the barbules act like Velcro actually. So this is a photo of what the barbules look like under a microscope, and you can see that the barbules have little branches on them, little hooks, so that when you bring them close together, they actually latch onto each other and form the feather again. So that's some of the amazing adaptations of the bird's body for flight. Allows them to fly. It also allows them to make these tremendous journeys, 4,000 to 7,000 kilometers back to Ontario, and then in the fall they're going to turn around and return to South America again. Thank you.